Good afternoon, everyone. Thank you for joining our session. I would be the MC for this session. Um, for this session, we have our CS senior student, Mr. Sophea Do, to present about his final year project, stock analysis. So can we have Sophia to start the presentation now?
Yep. Hello. Can you hear me? Okay. Okay. Yep. Hope everyone is doing well. My name is Sophea Do, and essentially I'm a CS student, year 4, and my final year project revolves around how stock or like a company stock, how it actually works, what are the data that comes along, with buying and purchasing stocks, and how technology has actually evolved, that industry, that finance industry, particularly in, stock analysts and financial analysts. And I was particularly interested in machine learning as well. And I found out that there has been a lot of breakthroughs for different models that can be used to help analysts, to help investment firms look into how well a company is performing and whether they should invest in a particular company's stock. So this is my agenda for today. I'm going to be introducing to you about more in details regarding the topic and how it was significant for me. Also going to be going through the methodologies, breaking down the model, what kind of data that I'm going to be using, where I'm collecting it from, and breaking down LSTM, or long short-term memory, which is the neural network. Finally, the third point will be regarding my findings and research. So one of the main purpose for my research was also I wanted to find out more regarding our stock market, or we call it the Cambodian Securities Exchange. Apparently we have one here as well, but I'm pretty sure most of us here know a little bit. Maybe some of us are experts, but essentially it's not really advertised much regarding how everything operates in CSX, and of course the future work, what I can add on, and the conclusion to my project. So if you want to go to my final year project website, if you want to find out more regarding the report, where all of the details, the diagrams and such are presented, you can scan the QR code and visit there. There's also links to the source code, instructions on how to operate the model and such, all listed in the website. So feel free. Okay. So yeah, I couldn't have done this project alone. There were a lot of people involved in helping me, going through this journey. So yeah, shout out to these three main people. My supervisor, Ms. Chan Sitia Tang, my co-supervisor, Mr. Li Ho Tang, who's also working at Prudential, and he's a financial expert. He's also working a lot with technology, so it was really cool of him to be able to reach out and help me. And of course, Miss Amy, which is my project coordinator. So so essentially, my motivation for this project, I knew that I was gonna finish uni soon, so I wanted to find other ways, to help me save money or maybe make my money grow. I was looking into a lot of different methods on how I could actually do that. Some people, suggested crypto. Some people suggested maybe looking into real estate, but I didn't actually have a lot of funds to start out. So I wanted to find something that I could just base a research on that could potentially help me in the future. And I thought about stocks because I've always heard how people, say invest in stocks, but how do you actually do that? Especially with technology, because of course I came from a technology background. I wanted to know if technology can help me gain an edge on if I were to start investing in stocks. And I also found out about CSI, so I also wanted to research more regarding how everything works here, how is it doing compared to other stock markets abroad. So yeah, so the objectives for my research essentially is one to really look into the current progress or current situation with the Cambodian Securities Exchange, whether they have any obstacles that they're facing, so on and so forth. Um, the second objective is to be able to utilize machine learning techniques and various neural networks that can help me create a model essentially that takes stock historical data as input and make some sort of forecast or you can say prediction as the final output and see how well it actually does. And finally, I want to piece together maybe certain recommendations and steps to help suggest to CSID because I did found out a lot of issues that they're currently facing, and maybe if they were to try and prepare to be able to handle this sort of technology, they have to take certain measures to help improve in terms of data quality, how to access data, so on and so forth. So yeah, that's the three main objectives for this research. So yeah, essentially I started with looking into CSI. I started looking into the second part, which is very crucial, was how I could actually collect data or historical stock prices from CSI. Um, just going onto the website alone is actually quite hard to navigate. I don't know how long they've developed that website for, but it was incredibly hard to try and extract data. But essentially, after spending quite a while, I was able to extract all of the historical data from all the firms that were currently listed in the Cambodian Securities Exchange. As for I also did historical stock prices from the bigger companies globally, like Apple, Amazon, Tesla. Those stock prices are very easy to extract. They have APIs for that, and yeah, it's super simple. You just have to import certain libraries. I'll show you that further in the demo. The next step would be forming the machine learning pipeline. um, yeah, essentially, if you want to reach your end goal, because yeah, so for our end goal would be the prediction whether our model performs well. You have to form the machine learning pipeline and making sure that everything works well. We have all the components that we have, and the flow is doing good, so that we can produce satisfactory results. And phase four would be working on the model itself, testing and going through trial and error to see what kind of thing works best for them. There are different kinds of parameters that you can tune, and essentially it can affect the final outcome for your model's result. And once everything is well and I'm satisfied with what I can do, with what the model can do, then essentially it's ready to be deployed or open for use, whether anyone would test. In a real life scenario, if a model will be developed, so like the same flow as I proposed, essentially you would have maybe a platform or website or a mobile app where you can integrate the model itself into the system, and it can generate real-time updates, whether it's an analytics dashboard or you would have certain interfaces that users or end users can use. But for me, I didn't deploy into a system like that. Essentially, the model is just open, and you can just go and input your own data, and then you can mess around with it. Yep. So yeah. So this is the machine learning pipeline. You have to first start with formulating what kind of problem that you want to solve. So there are various different problems in machine learning. There's classification problems, there's regression problems, so on and so forth. So for our problem, it was a regression problem. Essentially, we had input that came in the form of a time series that we want to generate an output that comes in the same form, and we want to compare whether it's doing really well or not. The second phase would be to collect data, of course, and making sure that it's pre-processed in a way that the model will be able to ingest. Um, So data processing is essentially cleaning up the data to make sure that you only have the columns that you need. So for example, the CSH data, they had a lot of other columns that were not used, were not needed within the model. So you had to clean that. There were also certain values that were invalid. And yeah, essentially after that, you create the model, you train it with your data set, and then you start tuning, making sure that all the parameters meet the optimum that you feel like is producing consistent results. And finally, you can evaluate the model and see if it meets the project goals. So here were the four main tools that I use throughout this entire research. I use Google Colab as the main real-time notebook environment. Essentially, you can host your own Jupyter notebook, and you can invite collaborators. There's a lot of pre-installed libraries for you to use, especially one of the main frameworks like TensorFlow and Keras. It was already pre-installed on there, and it was super easy for us, for anyone in particular. And yeah, you can just access it on the on their website, and yeah, super simple. As for Notion, essentially it's just a project management software that I use to keep track of my progress, any meeting minutes, discussions with my supervisors and project coordinator, and so on. Python was the main programming language that were used throughout the whole process of the development of the model. And TensorFlow and Keras is the framework and library that were used. They have a lot of neural networks, very useful functions, and so on that you can use to help develop your neural network. And yeah, everything has already been done for you, so you don't have to worry about making everything from scratch. So when collecting data, Yahoo Finance was one of the main data collection data sources, especially for stock prices or historical data. Um, there are APIs that you can essentially just write 2 lines of code in Google Colab, and you can already get that data into your notebook. All of the data is already prepared and clean, so you don't have to worry about pre-processing it another step. Um, as for CSH data, they don't have an API for that, so you have to manually extract everything. Um, by manually extract, I mean going onto their website and copying and paste all of the rows and columns into a Excel spreadsheet, and then you have to convert into a CSV file, and then you have to clean it. So yeah, that's the CSH data that I had to go through. As for the third one, is something that can be done in the future. It's a really good indicator for models such as stock forecasting, because essentially, if you think about it, a company's stock can go up or down based on certain things that happen. So let's say if a company has an executive that goes into a scandal, their stock price can fluctuate. It can drop, or maybe it can even go up. So that's the thing that's really good. And for data that you can use, essentially, people have used method where they can extract or scrape Twitter feeds or tweets that are related with that company, and you would have to apply like natural language processing in order to convert all of that data and making sure that it's suitable for your model to ingest. As for me, I didn't go towards that step, but it could definitely be something that can be worked on in the future. So here is the data format. As you can see, the picture on the left is the data format that was extracted from Yahoo Finance. Everything came like a pre-packaged. All of the columns that you would need is in there, and everything has been cleaned. As for CSH, however, there's a lot of additional data columns, so you have to clean and go through all of that. But yeah, but since there's only a handful of firms that are currently listed in CSX, so it's not too much work. But essentially, if you want to compare between a lot of firms locally or globally, you would have to go through a lot of manual work. So yeah. So regarding data pre-processing, essentially, if you want the model to be able to ingest the data well, you have to make sure that your data consists of only the columns that you want to analyze. Essentially, I kept all of these five columns because these are the core values that you would need. So regarding high price, so yeah, you're probably wondering what a high, low, open, close means. So in stock, high is the high price, meaning the highest price of that particular stock. So let's say if I'm talking about Apple, let's say in 2016, the fifth, on the 30th of the fifth month, the price of one stock is around $2.98, and the lowest price on that day would be 2.89. And the opening price is essentially the price of the stock when the stock market opens, and the closing price would be the stock price when the market closed. And the volume is essentially the number of stocks that were sold or traded within that day. And you would continue to collect all of these records as time goes on, and then you would have the historical data for that company. So yeah, essentially there are many tasks that you have to do when developing the model. You would have to first clean your data, making sure that everything is right in the right format, making sure that you don't have any null values, making sure that you only have the columns that you need. The third task would be to normalize the data so that you can use it in the algorithm. The fourth task would be training the model itself. You would have to split. So the general method is that you would split the data into two. You would have a training set and a testing set. You can choose how many ratio for each variable. But for my case, I chose 70-30. So 70% for the training set and 30% for the testing set. And finally, you would create the model, making sure that you have all the neural networks that you would need. And for our case, we'll be using the long short-term memory neural network. Yep, so I can head straight into the demo. Okay, so essentially I've broken down the notebook into two different notebooks. So this one is for exclusively global data. So you can see here I'm importing the data itself from Yahoo Finance library. There's also another notebook that I use for only local data, because there are certain ways, certain steps that you have to do that is different when you don't have an API in place. So I'll go through the global one first. So these are all the libraries that I imported. They're all going to be used in the method evaluation, in method development phase. You have a lot of you have your regular pandas, NumPy, scikit-learn, keras models, matplotlib for visualization, and of course TensorFlow as the framework. So this cell right here is for where you actually download or extract the data from. So once you install the Yahoo Finance library, you can actually download their historical data by specifying what kind of firm. So each firm would have all of these abbreviations for their company. So for Apple would be AAPL. This is Apple. There's also Amazon, Tesla, and so on and so forth. You just have to find out, what kind of stock market they're listed in and what is their abbreviation, and then you can just enter it here. Start is when do you. So this is where the data set actually begins and where it ends. So you can update it to today or to last week or whatever. As long as it's not into the future, then you would have the data. So once you download that, we just convert it into a CSV file. So this is something that, so in order to convert your data into a data frame, you have to convert your Excel file into a CSV or, to a CSV format. And once you're done with that, here's just a visualization cell to help you see. So essentially, Apple's stock price was under $20 in 2013. And now in 2021, it has gone up in around 150 or maybe almost 160. So yeah, it's gone up quite a lot. And so for the columns that we're going to be using, I'm only going to be working with the closing price. So that's why I would filter out any other columns that I'm not going to be using in this model. So after filtering it out, you can see we have a total of 2,129 records starting from 2013 until now. And now we're going to divide it into the two sets. So 70% of the data set is going to be used as the training data set. And the remaining 30%, we're going to be using it for the testing data set. So after you divide that, you actually want to normalize all of your data. So the reason we normalize it is that we do it so that our deep learning algorithm is able to understand. When you normalize your data, it means you're converting the data into a range between 0 to 1. So you can see this price here is going to be converted into something like this. So you can see it's 0.0 something until 1, and yep. So this the whole testing, the whole training data set is going to be normalized, and afterwards, essentially, yep, we store into another data set for use, so you can see what the data set actually looks like. So afterwards, you just have to convert the NumPy array into into three-dimensional. So you can simply assign it here, and then you reshape it. So you're probably wondering why three dimension. For LSTM in particular, the input that has to go into that neural network has to be three-dimensional. So the three dimensions is actually so this is the samples, the number of samples that we have in our training data set. This is actually the time step. So 70 is just what I chose. You can actually change it according to what you want to experiment. But for me, I chose 70 to be my time step. And essentially, time step is just the past observation for a feature, such as lag variables and so on. Finally, it's the feature. So our feature is going to be the closing column. Like yeah, we filter out. So that's going to be our only feature. So yeah, so once it's been reshaped into three dimensions, you can actually initialize the sequential class, and you just assign it to the model. Essentially, this sequential class is good for working with time series data. And yeah, once you initialize the model, you just add in your neural network layers. So the first layer would be LSTM. I've added 50 layers, and I turn the return sequence into true. And this is the shape that I want it to be. So the return sequence here is actually, so when you input data into a long short-term memory neural network, the output after that so when it goes into the neural network, it comes out as output, right? The output is actually in the form of a sequence. And if you were to put that data into another LSTM layer, you would have to keep it as sequence. So that's why we toggle it to true here, and then we put it into another layer. You can actually put it through as many layers as you want. It's a matter of trial and error. But for me, I'm just gonna work with 2 layers, and it takes less time to run. The more layers you have, the more processing power you need as well. So that's one thing to note. So after I'm done with my second layer, I can just set it back to false. So because after the LSTM layer, I'm gonna have it go through dropout. So I want to minimize the overfitting, and then put it through another dense layer. So dense here is essentially a layer that helps output the prediction that you want. And for dense layers, they actually don't understand sequences. That's why we have to convert it back to false. So now it comes back out as, as the input that as the same format as the input that we gave it. So it will be in 3 dimensions. So after that, yep, you can see here. Once this is the shape that it entered into the network. This is after it outputs. We toggle into true, and now this is how it's stayed. And these are the number of parameters that we had gone through. So after setting up your model, you start training the model itself. So essentially, you just write in a function called model.fit. You give it all the variables or the parameters that you have. So this would be our two variables, the dependent and independent variables. You have to divide your data set into batch sizes so that uh, the processing phase would have to go through each epoch. So then this is the number of epoch, or to put it simply, an epoch is like an iteration. So when you see this thing fills up, it means it's gone through the entire data set in one iteration, and we want the model to go through it 35 times, so 35 iterations before we are satisfied. As for shuffle here, normally when you put it when you're trying to train the model, it actually shuffles the data back and forth. We actually don't want that because we're working with time series, so the date itself is actually very important. So we don't want to shuffle it. So after we train that, you can observe that the loss of the function is actually starting to decrease. So what that means is that so imagine I have the input and I'm trying to predict something, right? So that would be my output, and how wrong or how right my prediction is has to be compared to something. So let's say the testing set is going to be used to compare whether my prediction is doing well or not. So if let's say the actual price or the actual stock price of that day is $2, but my model predicted 1.993. So the loss in that case would be the difference between the actual price and my prediction. So if the model, if you see that your model is the loss that it's without is starting to decrease, it means that your regression model is actually doing well. So that is the metric on how you can observe how well your model is actually performing. So this is what we can see here. This is the actual loss. So it's pretty low. It went up a bit, but it started to decrease as it goes on for each iteration. So after that, essentially, you just have to do the same thing for your testing data set, making sure that it's in the right format. And yeah, convert it into an NumPy array and storing it. Then you reshape it into the 3 dimensions, because we need to put it through the model as well in order to validate our predictions. So after you do all that, then you just have the model do model.predict, and you input the validation or the testing data set. And essentially, you also apply this function called inverse transform. So since the prediction will come out in normalized values or between 0 to 1, you actually have to inverse transform it so that it can come out in actual stock price, or in actual numbers, not just 0 to 1, but actual like $2, $10 or something like that. So that's why we did this model, this function. So afterwards, this cell here is actually just to visualize, your prediction. So this is the actual testing data set from here to here. So this is the training data set. From here to here, we use it the 70% as the training data set. The remaining 30%, this is our prediction of how the values is going to come out. So we actually want to compare that to the actual price. Yep. So as you can see, so the orange one is for the testing data, and the green one is for our prediction. So you can see that it's actually doing quite well. Maybe there's a little loss in each prediction, but so far it's following the trend really well. It knows where the stock is supposed to go and such. So that is actually really good for the model. So we can actually see how well it is doing for CSH data as well. So this is one of the firms from CSH, PWSA, or the Phnom Penh Water Supply Authority. Their stock has started since 2012 until now. It's not the latest one because you have to do it manually, so you can't really get any updated data. If you want to update it, you have to manually extract it again. So yeah, essentially follow the same procedures. And yep, as you can see, also quite well as well. For the loss function, it's continued to decrease as time goes on, which is also really good. Yep, and you can see here. So this is the actual price. This is our prediction. So yeah, really good. Only small losses for each prediction, which is really good. But yeah, there's a catch to all of this. So essentially, what we're doing is just a one step ahead prediction, meaning if I'm trying to predict the next day, so let's say if I have this prediction and this is the price, so I know my loss. I'm trying to make sure that the next prediction I do, I'm trying to minimize that loss, right? So I would tweak a little bit to see whether I can get closer or further to the actual price, and then compare it again, and then continue doing that until I get really good at that. And you can see that once you train the model a couple of times, they're starting to generate more and more good output, which is yeah, which is good. But if, let's say if I want to predict, 5 years into the future, or maybe even 2 weeks, how do my model actually do? So there's a lot of people who already tried that out. Essentially, it doesn't work at all. There's a saying by this person. He says that essentially you can give a blindfolded monkey a dart and a bunch of financial newspaper, and he can just throw that dart randomly and then choose to buy a particular company's stock. It would be as accurate or even more accurate than most financial analysts. Stock in its nature is very volatile. It's very hard to predict. So you have to look at a lot of indicators in order to help you get a better idea whether that company is doing well or not. So the whole process of this model essentially is just one of the many techniques that were used during the technical analysis phase. So for many financial analysts, they have a lot of things that they have to consider. They have to look at the company statement, their revenue, how they're doing, and that's for the traditional analysis methods. There's new analysis methods like what I did. There's also sentiment analysis. There's also a lot of other different indicators that can help give them a better idea. And there's many classification problems that they can solve and see whether they should or should not invest in that company. You can also try and apply different algorithms for day trading. But yeah, for me, essentially, this is just one small part of the technical analysis process. So knowing all that, we can go back, to CSH, right? So CSH or the Commodities Securities Exchange has been established in 2010. Currently, they have 7 firms. 4 are public and 3 private. And the last firm to join was AC in 2019. And according to my research, we are actually the second smallest stock exchange in the world, only behind Myanmar. And you can see by these stats, our largest daily trading average, so meaning the average amount of stock prices that are being exchanged each day, the record was only 44,000. While if you were to look at something like the New York Stock Exchange, they average around 3 to 4 billion trades per day. So that is a very big, big gap. And for the market cap for Cambodia, it only has 2.4 billion compared to the 26.2 trillion market cap belonging to the New York Stock Exchange. As for trading medium, most Cambodians recently they've been utilizing the mobile trading system that were created by CSH. So that's good because it provides a good method of introducing traders on how to actually acquire and buy stock in the CSH, and you can do it from your phone, which is really good. And this pandemic also brought in a lot more new traders and a lot more records that were broken recently. You can find out more information regarding that in my report. I listed it all down regarding how the pandemic actually had some impacts on what CSX has been doing. Um, but yeah, compared to the 2,600 firms that are listed on NYSE, CSX only has 7. So adding up all of those statistics, realize there's a small firm. Majority of our population actually does not know about stock in general. Um, the government or the educational sector does not really emphasize much on how they can actually introduce the financial literacy portion into our education. Um, yeah, high school, you don't really have much knowledge regarding all these things. So if there's going to be low financial literacy, there's also going to be low demand because most people don't know what stocks are actually there for. Um, and and if there's low demand, that means it's more likely that most firms are not interested in IPOing into CSI. By IPO, I mean the initial public offering. It's essentially putting your company up and saying, okay, we've divided our companies into 2 million shares. You can become shareholders in our company. So that's what IPO is for. But yeah, so if there's low demand, investors are likely not interested in coming to our stock exchange or coming into Cambodia to see that sector and invest. And yeah, and finally, if there's little firms, it means there's going to be little data to work with. So if you were to develop a model, there's not a very big variety for you to test and validate your model with. So you don't really know how well it can actually be implemented in a real world scenario. So let's say you're working for a investment firm, you want to see how well they're going to do, how well a company is going to do within a certain period of time, and you want to factor in all of their data, all of their financial statements, revenue, so on and so forth, and seeing whether it's really worth it to invest in them. In the case of CSH, that's not really possible because there's not enough data to work with. So so basically, I've tested the model out with all of the data set that I were able to extract from CSH. So here are the six local firms. You can, essentially this is the water supply. This is Pest Tech. This is the autonomous port. This is, I've got a name of this. This is AC Bank, the bank, and this is Grand Twins International. Oh yeah, this is the autonomous port. There's 2 different ports, one in Sihanoukville and one in Phnom Penh. This is compared to how well the model does for data from Tesla, from Apple, and from Amazon. So yeah, in a sense, you can see that it's doing really well in terms of how the trend is going. You also have the regression table that let you compare the difference and how well in terms of value or regression that your model is doing. But yeah, essentially, there's a lot of things that can be done to help enhance this research even further. So the first thing I would recommend to CSH would that they would have a way that allows more people to be able to access their data more easily. Their user interface for the website is not user friendly at all. And for for analysts, they don't want to manually go through all that data, especially if there's a handful of firms or maybe a lot of firms. They don't want to do that. They just want to write 2 lines of code and and get all of the data that they need. So if CSI want to appeal to all of those possibilities, they would have to work on one, better interface, and one, they would have to create a data API for analysts. And of course, this problem is probably not easy to solve. Is that they would have to onboard more firms, and of course, furthermore, if they have an abundance of data that people can work with, there's also the possibilities of building recommendation systems using the data in our stock exchange that can help recommend which company to invest in, how to prepare for that, so on and so forth. And it's not really possible without the presence of data. And even for sentiment analysis in Cambodia is also quite tough because natural language processing, it's not really open for like operating with the Khmer language. So you have to go through translating and then training the model to make sure that your sentiment data is a good indicator. But yeah, there's still a lot of things that you can possibly do to help further and prepare. But if we want to appeal to more investors, if we want to onboard more firms, there has to be certain steps to be taken in order for that to happen. And yeah, so as a conclusion, there's still a lot of time for CSA to work on gaining more awareness, improving their website, or maybe having a better method of extracting their data. And there's still time for them to kickstart maybe a program or initiative that could onboard more firms, whether it's larger firms or like SMEs. But yeah, in the meantime, us as individuals, well, why not learn about all of these technology, all of these analysis techniques, and how to extract all these data. And I think if we were to start start from somewhere and look into the possibilities of learning about all of these data and applying it, I think would be really good as an individual as well. Yeah, I think next up would be definitely sentiment analysis. It's also another technique, but yeah, it's really interesting on how it actually works. So yeah, I think that's it for my presentation. If you have any questions, feel free to list it down, and I'll try my best to answer. Yep.
So thank you so much, Sophia, for very insightful presentation. So I think our audience have a question in the chat. So can you please read and answer that?
Okay. Yep. Yes, Miss Serena. It would definitely be more interesting. Yeah, I can actually add that into a notebook itself, but is from what I've seen, essentially they always try to plot the loss for every iteration and see whether it goes down or not. But yeah, for prediction in the test that they use, yes, it's a one step. So it's only one step prediction. So once there's a new prediction, it would use that as the input and then predict the output for the next prediction. So yes, the answer for that question would be yes. Yes, the source code is actually in the final year project website. So I can actually show you. Okay. So all of the materials regarding the report, my previous presentations, the source code, instructions on how the model works, so on and so forth, is actually listed here. You can actually just go and explore. So yeah, most of the source code is being stored here, and you can go on duplicate the model and test out for yourself. If you have a data set that you want to try out, if you want to explore you can go on into the model, change the little parameters, added a bunch of notes on there. So in case you want to try out with your own data set, then you can actually do that. I forgot to mention, so if you want to analyze your own CSH data, let's say you want to update it, since I haven't updated since 2 months ago, you actually have to put it through this pre-processing notebook. So this essentially helps you so before you have to do it manually. You have to manually clear out certain columns, find certain data that is null. So the cleaning process is actually done in here for you. So you just have to replace your data here. So you upload it. So once you run the cell, you can upload your file. Once you upload it, you just change the name, specify which file that you want to convert into a CSV file, and then you just follow this. So for the drop here is all the columns that you want to drop that you feel like you don't need. So just list down all those columns here. And yeah, I think once you change this, and this, you can essentially clean your data set automatically, and then you can run the file, or just copy these two cells onto your own model, and then do it from there. So essentially, you don't have to worry about whether the data doesn't work for the model, so on and so forth. Yep.
Okay, thank you for your answer. So, is there any question from our audience? Okay, so I think for now we come to the end of the session. If there is no any other question, since we already over time. Okay, so thank you, Sophia, for sharing, and as well as thank you to our audience for taking off your busy schedule to join us today. So we have another session of a final year project presentation as well. So please go to visit our IT Day website and find a link that for the topic that you're interested in, and see you for another session. Thank you, everyone.